Thank you, sir. On behalf of FOS family, I will request our respectable Dean, sir, Professor Amarendra Narayan Mishra, sir, to address the gathering.
Jai Gurudev. Good morning to all of you. Revered Professor Sharma, our Honorable Vice Chancellor of Sri Sri University, honorable guests of this auspicious ceremony, the National Science Foundation Day, Dr. Biplav from IMMT, Indian Institute of Mineral and Metal, and Dr. Jayakrishna Panigrai, who is an eminent environmental scientist. All of you must be seeing him in TV and other media. He is a prolific writer in environmental science and a columnist. My colleagues, Professor Bhatt on the dais and other colleagues sitting off the dais, our Deputy Registrar, Dr. Ghosh, invited guests, and my dear students. I invite all of you to this August gathering of National Science Day celebration. All of you know about National Science Day. I need not have to waste time because we are here to listen to the dignitaries and guests about their views on Science Day. I am happy that Sri Sri University Faculty of Science, which is having different subjects like physics, mathematics, environmental science. We are going to start biotechnology, life sciences, and chemistry also. Science discipline is growing in this university and will grow in future. It is a wonderful university. All of you must have seen it. With the blessings of Gurudev Sri Sri Ravishankar, this university started, and it is one of the best serene and peaceful university campus I have seen around the country and abroad also. When you enter into this campus, you feel how our science have developed in centuries, not today. All of you can understand English, or I should talk in Odia? Okay. If all are not understanding English, ମୁଁ ଓଡ଼ିଆରେ କହୁଛି। जो छात्र छात्री माने आଜି एଠିକି ଆସିଛନ୍ତି, जो स्कूल रिप्रेजेंट करिछि सेमानकु ମୁଁ धन्यवाद दउछि। आଜି समस्ते एकाठी ହେଇଛे एई श्री श्री यूनिवर्सिटी रे, सेति बहुत खुशी लागुछि। आपण मानकर साहाय्य सहयोग पई आमे माने गर्वित। एई पिला मानकर पिलानु देखिले एवं आमे जतले सेई बयसर थिलु, आमर केते उत्साह उद्दीपना थिला विज्ञान एवं वैज्ञानिक हवा पई आमर जो स्वप्न थिला ता साकार हेछि। किंतु बहुत अध्यवसाय करिया पड़े विज्ञान किंबा वैज्ञानिक हवा पई। बहुत अध्यवसाय दरकार, कठिन परिश्रम दरकार। एवं ए पिला आज एकविंश शताब्दीर पिला माने कौन सी क्षेत्र में कम नुहति, से माने बहुत आगे। आज जिते आर्टिफिशियल इंटेलिजेंस AI कौचे सबु क्षेत्र रे पशिलाणी यही पिलामानकर इंटेलिजेंस जे केते बढ़ी गलानी सेटा भाविया बहुत कष्ट। आजिरा प्रतियोगिता अच्छी पिलामानकर उत्साह उद्दीपना देखी मते पुनर्बार गोटे पिलाटी हवा को भल लगुच एवं इच्छा होची किंतु बयस बढ़ी जाइछि पिला तो हो पारि ना किंतु तुम मानकर गहन रे मु आज बहुत आनंदित एवं भावुची एमती प्रति क्षेत्र रे आपण माने आमको सहयोग करिवे एवं आमे एकाठी आगु जीवा। धन्यवाद। थैंक यू।
Thank you, sir. We have on the dais, we have our guest of honor, Dr. Biplab Kumar Patra, sir. Dr. Patra has completed his PhD from Indian Association for Cultivation of Science, Kolkata. Then he has done his postdoctoral research in atomic and molecular physics of functional complex matter from Amsterdam, Netherlands, with Professor Eric Garnett. He was awarded with CSIR Net, GATE, PST, Travel Growl. I will request Dr. Patra to address the gathering. Thank you, sir.
So should I speak it from here? Yeah. Say.
You have a pointer?
Okay, good morning. Good morning to everyone. So, I have to speak either in English or Hindi because I cannot speak Odia. I am from West Bengal. I can speak Bengali. I think you will not understand Bengali. So, which language you will feel comfortable? English or Hindi? English, good. Okay, so I can see most of you are the school students. Maybe some of you are from college, like in, yeah, please. But they told that they will listen in English. Good. All right. So I made the talk little bit general talk, but some of the things like I was told that maybe some engineering students like the bachelor students are also there, so made the talk a little bit more scientific. So I'll try to convey the message what exactly we are doing at CSIR Institute of Minerals and Materials Technology, CSIR IMMT Bhubaneswar, and how it really relates to the direct benefit to the society. All right, so today I will talk about the semiconductor. So first thing, I think, how many of you heard about the semiconductor? Can you raise your hands? Ah, good. I can see, I can understand you will definitely know it, but I can see there is a very small kid. Yeah, can you please stand up? Can you just tell what is the, tell me what is your name? Sati Datta, okay. So in which class you read in? Huh? Class 9, good. So you know about the semiconductor? So what is that? Can you please explain a little bit?
Sir, it is a mixture of metal or maybe non-metal that allow electricity to pass, though may not be allowed in certain cases. This is semiconductor.
So then I think I'll give a good talk. Good. Very good. Sit down, please.
Thank you, sir.
So I was kind of a little hesitating like how I can introduce our research. So semiconductor, she told very nicely and very true, is that metal is a conductor, we all know it, right? And if we allow the metal to make a discrete band levels so that electron will flow only after certain conditions. Like if we put some external energy like light, so that the electron will flow from valence band, lower band to the upper band, and we will get the electricity. The best example of a semiconductor is in our real life, like the scientists are really putting much effort, is the solar cells. I think everyone will know about the solar cells. And also, another example of a semiconductor applications is the LED, right? Whatever the lights you are seeing here, this white light, all are the made of semiconductors. So this is the gallium arsenide semiconductors are there, okay? So, okay, let's move on. So I'll talk about the semiconductor halide perovskites for next generation electronics. So the current generation electronics and the next generation electronics. So I'll make a bridge between past development and the recent development, and how we can really implement those kind of materials to the direct benefit of the society, like the poor people and to the villages, something like that. And why I'll choose this topic in this today's date, because today is the National Science Day, and you all know Professor C.V. Raman, who discovered the Raman effect on this date, on 1928. So before that, I will introduce myself. So I am a scientist working at CSR IMMT since 2020. And then before that, I did my PhD from Indian Association for the Cultivation of Science. You can see the cultivation picture. So this is the recent development of the Indian Association for the Cultivation of Science. We call it as IACS, okay? And this is very significant in the today's date, because C.V. Raman did all his experiments to get the Nobel Prize from these institutions. So I am privileged to be a part of that institutions doing my PhD from there. And after that, I went to Amsterdam, the capital of Netherlands. It's a very beautiful country, and the institute is Atomic and Molecular Physics, AMOLPH. You can search it in Google. It's a very good institute in nanomolecular optics and photonics. So I was hired there as a chemist to make materials for solar cells, LEDs, transistors, this kind of things. So I stayed there for 3 years, and after that I joined here at CSR IMMT. All right, so this is the Professor C.V. Raman, you all know it, and you can see on the left side, the images, those are the colleagues of Professor C.V. Raman when he was working at ISCS during 1920s. So he is sitting in the middle, and some of our scientists from ISCS are also there discussing about certain facts. Okay, so let's have a look to the Raman spectrum. Can I use the pointer to? Okay, fine. So you can see on the right hand side there is a spectrometer. And Raman used on 1920, like 1920 to 1928, used that spectrometer to identify the Raman spectrum. So that is itself now preserved in the ISCS museum. I took a picture recently, last month I visited there, and they made a very nice, like a museum kind of things there, and they put the spectrometer over there. I took that photograph. You can see that, and if you visit sometimes in Kolkata, you can visit that museum, or you can call me, I can arrange a visit for you to have a look on that spectrometer, from where Raman did the Raman spectrum, and from that he got the Nobel Prize. And that is the only one scientist in India who got the Nobel Prize from India, like doing the research from India till now. So till now, we are trying to do some more science, more things are there. So what exactly is the Raman lines? You can see on the left-hand side, this is the first Raman signals from that spectrometer. He got it to like characterize the Raman vibrational modes. like naturally, what exactly the Raman vibrational modes. I will tell you little bit in a very general way. So, as she told, say semiconductor she knows, so obviously we all know about the electronic energy levels for any material which is not a metal. I am not talking about a metal. So, electronic states and the vibrational states and the rotational states, right? In I think we almost everyone we know about the microwave oven, right? So the microwave oven is provides the microwave radiation and it excites the rotational energy level of the water molecule so that it goes to the higher energy level, right? And that's why the water gets heated, and that's why we get cooked food. So similarly, the higher energy discrete level is the vibrational energy level of each molecule is there. So what exactly is that? If you put a certain amount of light, I put a very schematic, simple schematic in the middle, certain amount of light, and if the molecular vibrational energy level absorbs that light, so the molecule goes from lower vibrational energy level to the higher level, right? This is the simple thing. Sometimes, like before the Raman's discovery, this is the natural phenomena people knew, that if we put the light and the molecule will go to lower vibrational level to the higher vibrational level, and then it scattered some light, and that is the Rayleigh scattering. But Raman, using that spectrometer, identified that if we give, say suppose 10, say just a quantifying, we give 10 amount of light and 10 amount of energy, and get 10 amount of scattered light from the material, then it's a Rayleigh scattering. But the things not happen in the material which have the vibrational states. Sometimes the energy which is absorbed by the material, it will be scattered, maybe higher energy, maybe the lower energy. So that is the invention, like it's not exactly the same energy scattered, sometimes it's higher energy, sometimes it's lower energy. And that is the discovery, that is the Raman signal. It's called as Stokes shift and anti-Stokes shift. That is in more understanding, more science. I'm not going to the detail on that. So you better know that if we put a light onto a material, it absorbs some light and scatters some light. So if the scattering happens, if it's equal to the absorption, equal to the energy of the incident light, then it will be a Rayleigh scattering. But if it's not equal, then that is the Raman scattering, you can say that. And that is the Raman's discovery, he first did that. All right, so this, what is the importance of this? Because in daily life, we do this kind of technique as a characterization tool of our material, what we synthesize in our daily life for, like say for solar cells, say for LEDs, say for transistors, this kind of things. So that is why it's a basic characterizations technique. We have it at IMMT. We have a beautiful Raman facilities there. We have also different facilities. You can have a look. This also we have there, so that we can identify the vibrational states of the molecule, and that really impacts the quality of the final material what we use for this kind of solar cells, LEDs and transistors. Okay, so I tell a brief of solar cells, that if we put light, we get the electricity, simple, that is the solar cells. Similarly, in the LED, here you can see all are the LED bulbs, and these are the very cheap bulbs. So here we inject electrons and hole, and we get light. And transistors, everyone has a mobile phone, right? And those are made of the very small transistor units, and those are nothing but the semiconductors. All right, so I'll give an overview of a semiconductor, how it really impacts to the direct benefit to the society. You can see here on the left hand side, it's a solar cell panel, and it directly connects to a like a capacitor, and then it connects to the house build, like in everyone, whoever has the solar cells. And then we can also carry forward that solar cells electricity through from Odisha to West Bengal or something like that, right? till now it's not so much developed because the current solar cells available in the market is based on the silicon, and that is a bit expensive, so that the poor people, the village people cannot afford it. So from that point, our research starts that how we can make such a material as a chemist. So I am a chemist. We try to engineer material which will be very cheap, very stable, so that we can make any kind of this kind of devices so that it can be affordable by all the people of the society in India. So you can see here, I think you can hear my voice. So I can go here. So in the middle, you can see the solar cell, and you can stand here. That will be good actually. Great. So you can see this is the cell, and what exactly is happening inside the cell. This is the thing, we do it in the laboratory scale. So what we do, we synthesize materials in the nanoscale. You can see here, this is the nanoscale materials we synthesize, and then we accumulate to make it a larger scale, and then we stack it like this. So this is a material stack of any kind of devices, and then we put different geometry of the devices, and then we put light on it so that electrons and hole will be generated. You can see here, this is the light, and you told that it's a semiconductor. You can see this is a semiconductor structure. This is the lower band gap valence band, and this is the higher band gap conduction band. Light falls, electron will come from here to here. So electron and hole generates, and our job is to extract the electron and hole so that we can get it to the electricity. If we get the electrons and hole, so that we can lighten our lamp, we can the switch on the fan, everything we can do that. So our job as a chemist, what we do is to synthesize, engineer the chemistry of these materials, how we can make very cheap, very robust, and large scale production of the material, so that we can, like the industry people can use those materials as a basic backbone of this kind of large solar cell structures. So this is one example, okay? So I will not go in details on this, but I will give you one example. There is a, okay. So I'll say one more examples of the, like how we can directly benefit to this using this semiconductor. I think everyone knows that the kids use a certain kind of balls, and if you put the ball inside, like on the floor, you can get some electricity, right? Everyone knows it, right? How many of know you this fact? Can you raise your hand? That is certain ball the kids play, and if you throw it, you can get some electricity. Yeah, you can get some light. Yeah, please, again, stand up, please. Yes, yeah, also in the shoes, like when they walk, you can get some electricity, right? You observe that phenomena? What is your name? Nivedita Bera. Okay, good. So can you please tell that what exactly is happening there? Yes, good, force. And then, so which class you read in?
So class 8.
Good, okay. So then like when you walk, you see also there are some sounds are coming, pick,
Yes,
sounds are coming, right? And also the balls, if you throw it, we get some light. So the बच्चे बहुत excited हो जाते हैं. What exactly is happening there?
So
Try करो. Force is very good. ये class 8 student ऐसा बोला, this is very good. ठीक है, no problem. Anyone else? I saw one hand here. कुछ भी try, जो दिमाग पे आ जाए बोलो. घर पे तो everyone knows this phenomena, right? Okay, yeah, I understand. So anyone from this side? All right, it's fine. So this is also another phenomena related to the semiconductor, and that is called piezoelectric effect. So I put a small cartoon, somehow it's not coming here, so I'll skip that. Anyway, so what exactly is happening? So this is that's why I put it as mechanical energy harvesters. So the previously, what about I told the solar cells, that is the solar energy harvesters. This is the mechanical energy harvesters. Mechanical energy harvesters means we are putting some force and we are getting some light, electricity, right? That is the piezoelectric effect. So the semiconductors, if the semiconductors have some polarization, like positive and the negative charges on it, distribution of charge, then if we press, like if we put some hammer on it, like we are putting some force, right? Then we'll get the electricity. That is the natural phenomena of the piezoelectric effect. Like if we put some force, we'll get some polarization and also we'll get some electricity. So that is the phenomena. Okay? Good. Please sit down. So these are the natural semiconductor materials we use in our lab to synthesize. So say called halide perovskites. It's a semiconductor. I'll not go in more beyond details, but its applications is that solar cells, LEDs, and the piezoelectric nanogenerators. I'll mostly talk on these kind of natural phenomena. Okay. So what we do exactly? First we synthesize the materials, and then we do some self-assembly, like the materials, if it's like this kind of particles kind of things in the nanoparticle range, it's a quantum dot, we say, we self-assembly so that we can make a large-scale self-assembled structures, and then we make the devices using the stacking of these particles to collect the electricity. Okay. So this is the like a synthesis techniques naturally we follow. You can see here a small video that just by changing the size of the particles, we can change the color of that molecules. So that is the beauty of the quantum dots. Like if we want to get a blue color LED, if we want to get a red color LED, if we want to get a orange color LED, like we have all kind of varieties of LEDs are available in the market, right? And those are nothing coming from these materials from the lab. Like before me, some scientists from different countries invented that, and that's why we are getting and benefiting these. And we are getting this white light because here, three colors, blue, green and red, three LED are mixing together to get these white LEDs. So we are also working on that, how we can develop a cheaper technology from India itself, that so that we can replace the gallium arsenide LEDs which is coming from the outside, like they are patent techniques. Okay, so these are the quantum dots, and it exactly looks like this. It's very small scale particles. It's around 5 nanometer particles you can see here. This is a transmission electron microscopy images. And then we get like a micrometer and a millimeter scale self-assembled structures. You can see here. I think you will be able to see that. So if you, so 2-3 nanometer particles, we are able to arrange it in a large scale. You can see these are the 1-1-1-1 particles. And we do the controlled self-assembly so that we can get a monolayer or bilayer self-assembled structures to get the final device that we need for this kind of final device structures. Okay. So we can also do a self-assembled structures in 3 dimensions. You can see here. So this is a 10 nanometer particle, and then you can see this is around 20 micrometer 3D block, 20 micrometer X, Y, and Z. Okay, and these are made out of these 10 nanometer particles. So the beauty of this kind of giant particle is that the property of a single particle and property of this particle is different in terms of the luminescence. So that is why we call it as a superfluorescence, and that is used naturally now in the recent LED materials. I'll not go more onto that, but I'll go to the interesting part. Is that first I will explain. We developed a recent material on cesium, titanium, halide perovskites. So based on the titanium, which is very cheap, which is earth abundant and also non-toxic, and we made a solar cells out of it, and we are just trying to implement that cell in a larger scale so that at least we can commercialize in the smaller dimensions, and that will be useful for the society. So now this is a very interesting phenomena I'll tell. So what is that in the picture? Can anyone say? what is that in the left side? Raise your hand, please. What is that in the left side picture? Yes, please stand up. Yes, good. What is your name?
Sir, Aishwarya Priyadarshini.
Okay, which class you read in?
Sir, standard 9.
Good. So this is a wallpaper of, this is a display of the mobile phones. Everyone has the mobile phone. Okay, so you stand up. I'll ask you more questions. So now, what is this?
Sir, Wi-Fi.
Good. So this is the Wi-Fi, and we can get this white signals. Okay. So what is this?
Sir,
Eh,
that
yeah.
part.
Yeah, that part, a small part of the Wi-Fi. And anyone knows about what is this? All right. So I will start my story from here. Okay. So you can sit down. So everyone knows up to this, right? Everyone has a mobile phone. Everyone has a Wi-Fi. Everyone has a color display. And if we closely zoom at this, any of this, I put the Wi-Fi because just for the clarity, if you closely zoom at it, and if you put it, the mobile phone, under any simple microscope, optical microscope, yeah, I think here optical microscope is there. If you put it underneath the optical microscope, in 60x zoom, you will see like this. For a very small in dimension. So what exactly is this? I just told you previously that white light is made of blue, green and red combinations, right? So if you put any of your mobile phone under the optical microscope, you zoom it, you will see these kind of pixels. These are the pixels. I think everyone has a TV, LED TV. It's not possible to put the LED TV under the microscope, but it's possible to put the mobile phone under the microscope and you can see the pixels. So what exactly see? You can see this is blue, green, red combinations, right? And this is in the nanometer scale happening. Nanometer scale. This is the 100 micrometer. So all length, it will be maximum around 100 micrometer. And the pixels are made in the nanometer scale. So there, the blue emitting material, green emitting material, and the red emitting material are self-assembled in the nanometer scale. So how is it possible? How is it possible? Like if we ask, can anyone say any guess? Like how is it possible? Like we cannot even see a nanometer kind of particle, right? We cannot see. So how is it possible to place those particles, very small, tiny particles, into a well-ordered manner like this? So I will start, like I will say, so yeah, okay. So I'll just say one thing. So this is actually my mobile phone when I was in Netherlands. So now after I think maybe around 4 or 5 years now, this is my current mobile phone. I put it for you. What is the difference? Is there any difference? Can you see? Can anyone observe that? So this is the mobile phone 5 years ago, and this is the mobile phone, the same mobile phone, same model. This is now. So can you identify a difference? The difference is that the scale gets smaller. So the drive towards very smaller dimensions. So that is the beauty, and that is the desire of a researcher as a scientist, that how we can make a very small, बहुत पतला कैसे phone बना सकते हैं, very small display रहेगा, उसका अंदर मेरे को सब features चाहिए. So the scientists are playing on that. So how we can make it? So the simple thing is that nanolithography, okay? So I think everyone will not know, but some of you might know about the nanolithography. So it's a simple thing that we make our substrate, and then using the lithographical beam, like if we want to make a straight line in the nanoscale, we can do that. So we make a straight line in the nanoscale. If we want to make a circular pattern, we can do that using the nanolithography. So it's a technique, just like a drawing or painting. Lithography, if you search it in the Google, you will see that painting, patterning, okay? So it's a very small scale electron beam will draw a pattern for you, whatever the pattern you like. So for these cases, the industry people uses these straight line patterns. Now it's a square pattern, and now people are moving for a single dot patterns, so that the display of the mobile phone will be very small and you will get everything. So it's a simple thing that we draw these patterns using the E-beam lithography, and then we deposit our particles, the small particles, using a self-assembly. How we do that? So we put our substrate on the bottom. I'll show a video, very simple video. And then where the pattern is there, on the substrate the pattern is there, and on the top we'll put another substrate, and in between capillary effect, everyone knows it, right? Everyone knows the capillary effect. So if we sandwich the two substrate, and then in between that, if we put a droplet of solution which contains these emitting particles, and then we drag it, so the particles will move, and see on the patterns it will be deposited. So that is the simple capillary technique we naturally follow. And then you can see here, so if we want to get a red emitting particles to be deposited, you can see here, this is the particles are deposited like this. So for this kind of displays, the companies use this kind of square geometry, and then they take this kind of particles, and then they deposit onto their display devices. So that is on that aspects, like the simple thing is that first we have to take the particles which has some emission like blue, green or red, and then these are our interested particles domains, like we choose the cubic particles, here also cubic particles of different material. It's a nanoscale, and then we use this template from our collaborator from IIT Kharagpur, and then we pattern these particles like this. You can see here. So this is the like a large scale view of this template, and then we pattern the particles like this. See, the capillary assembly, we can place the particles inside it, so that whatever the pattern you want, the particles will be deposited like that. Okay, and then we print it onto a larger substrate where we want to get our particle, and then we do some further processing to get the final device structures. So another technique I will say, so I'll say just the video. Is it possible to switch on the video? Like naturally we do, the particles we deposit on the bottom, and we use our template from the top, and then we just press it. So due to the capillary action, the particles will be you see here the video, simple video. See, the particles are deposited on the bottom with a little bit of solution, and the patterns are there on the top. We place it from the top. Please play it again. See, and then you take it out. The particles are arranged according to the patterns on the top. So that is the simple technique we are trying to develop, so that at least we can make some large scale printing, and then further implement to the society, working with some companies, so that they can use these techniques for making this kind of displays. So this is also another technique, like roll to roll printing. Like this is our patterns, and we put our particles inside it, and then we just roll it. Just simple roll it. So due to the capillary force, capillary actions, everyone knows it. In the standard 10, standard 12, we know it. So due to that, you can see here how the particles are arranged throughout the whole area. And this is the thing on the display. You see that in the mobile phone. So if we can develop that, and if you can make it cheaper from here in India, then we don't have to buy Apple phone. We don't have to depend on the China phone. We can make our own phone from here, and then we can sell it and in a better price to our society. Just not only from the phones, for like computers or any other displays. All right, so these are the different patterns. So these are the different patterns we made, and you can see here, this is the luminescence. You can clearly see that this is exactly the grid patterns what we see in the optical microscopes, like that. I have 1-2 minutes, few more minutes. All right, so these are the different materials we are trying to develop it, and this is the techniques like where we exactly do that. Like maybe there is a small video, please switch on. So this is our substrate, this is the top substrate, and the liquids are there inside with the particles. You can see this top part will move. So the meniscus here will also move, and the particles on the meniscus will be deposited onto the substrate according to the patterns. It's very simple techniques. All right, so this is the overall general overview of the materials what we recently developed in our lab. And now to characterize this material, this is an antimony based material. We use the Raman, like you can see here. I just told you that whatever the applications you do, you have to characterize the materials first. And for that characterization, one part is the Raman vibrational mode, whether the vibrational modes of like the C and stretching and the NH2 rocking, NH2 bending, these kind of modes are really there on the materials or not. And that is the fundamental aspects of Raman. Whatever the materials we synthesize in daily life, you have to characterize either Raman, XRD or IR. So this is one typical example of the material. I'll not go to the details of that. So these are the materials we are trying to implement for those kind of applications. This is another kind of interesting material we recently developed. This is a very single crystal, and it's a very pure single crystal with very high electrical conductivity. You can see here, this is a hollow structures, like inside is the hollow. And this shows very nice piezo response properties. Like we are trying to make a device out of it so that we can use this as a toy, like the kid's toy or the kid's shoe. I'll show the example of this. So to be a piezoelectric material, first the material has to be shown the ferroelectric properties. What is the ferroelectric properties? Like if you put some electric voltage, you will get some polarization. And if you remove the electric voltage also, still you will get the polarization. And that is the significance of this beautiful hysteresis. I think this is more under to the science. So the hysteresis is coming, means you can see here at 0 voltage, there should be some current. That means this is a typical ferroelectric material and also the piezoelectric material, and that material can be utilized for piezoelectric materials. Okay. So this is also our recent, we have a beautiful piezo force microscopy, and there, like you can see how the volume expansion are happening. So this is the film, and if we put some voltage there, you can see some volume expansions are there. Means volume expansions means that is the piezo property is there, and that will give the electricity. So that is a simple characteristics. If you want to know more in details, you can talk to me. And yeah, so I'm done. So this is the laboratory setups. I have basically, after joining, I joined in 2020, just before the COVID. So we had a very tough time during 20 to 2022. But we developed the lab. So this is my lab, and we have the chemical vapor deposition setups and the slank line synthetic setups for synthesizing the quantum dots particle, what I showed. And we have also the glow boxes, like sometimes some chemicals which is like air sensitive. So we put that inside that. We also have a UV chamber to see whether the material is luminescent or not. And we have an automatic dip coater. This is very beautiful to make a large area film. Like we synthesize the particles and then we dip it and then just leave it so that you will get a beautiful film. And also the spin coater, and I didn't put the plasma cleaner to make the devices. These kind of setups are there. Recently, I also bought a atomic force microscopy which contains this, the PFM, like how we can measure the surface topography of those kind of devices. These are the setups we have. And then I want to thank my head, HOD, and my director, and my collaborators. And these are the funding agencies from SERB, DST, SERB, and then CSIR, of course, and IMMT, my institutions. And these are my PhD students. I think these last 3 students already got a job. So they already left in the middle. So Yeah, the first two students are still working. And of course, the Sri Sri University for giving me this opportunity to give a lecture to the public, like to enrich our science, how we can at least spread the science, what we exactly do in the laboratory. And I hope I can give a small glimpse of the nanoscale science to the public domain. At least you will know something that what exactly is happening or how it can happen maybe when we will grow older. Thank you very much. So if you have any questions, you can raise your hands. No questions. So you understand at least something. Good. So then I will hand over the microphone to the organizers. Thank you very much.
Thank you, sir. Thank you for giving your spacious speech to us. Today, we also have Dr. Jai Krishna Panigrahi, sir, with us. Dr. Jai Krishna Panigrahi is a renowned geologist, environmentalist, and educator with 37 years of distinguished teaching and administrative career. He has inspired and influenced thousands of students and colleagues with his passion, knowledge, and dedication. Dr. Panigrahi is a prolific writer, TV panelist, and a member of many learned societies. For his outstanding work on environment, forest, Chilka biodiversity conservation, he has been awarded with more than dozens of state and national awards. Dr. Panigrahi was also a guest researcher in universities of Germany and USA. Presently, he is working as a secretary of Odisha Environmental Society. I'd like to request you, sir, to please come here and present your talk. Thank you.
Honorable Vice Chancellor, Professor Sharma of Sri Sri University, esteemed Professor Mishra, Amarendra Narayan Mishra, the Dean Science of Sri Sri University, Professor Bhatt, and all esteemed faculty members of this great university, and most importantly, whom I consider very dear to me, to my heart, dear students. I consider you as the beautiful budding flowers in the garden of Sri Sri University. On the eve of celebrating National Science Day, I extend my hearty wishes to you all, my compliments to you all. Oh, they are from different schools. Okay. So thank you for your kind presence here. I wish to thank the authorities of this university for inviting me to this occasion and sharing some of my thoughts with you. How many of you do not understand Odia? Please raise your hands. Okay. Very few. I think because students, young students are here from schools. So I would prefer to speak something in Odia so that you can grasp the things. Point here. Yeah, we are living in the age of science and technology. Starting from early morning till we go to bed in the evening, whatever work you do, can you please tell me anything without the help of science and technology that you are performing? Starting from using the brush and paste till the end when you are going to the bed watching your mobile phone. Whatever you use throughout the day, so we take the help of science and technology. The great man already, Dr. Biplab has explained about Dr. Sir C.V. Raman, Chandrasekhar Venkat Raman, the first Indian, first Asian, non-white person to win Nobel Prize. In physics in 1930, for Raman effect, he explained very well. He was working in the laboratory of Indian Association for the Cultivation of Science in Kolkata. He was awarded Bharat Ratna in 1954. He got Nobel Prize in 1930. And we have been observing National Science Day since 1987 on this day. And this year's theme already discussed, indigenous technologies for Viksit Bharat. Prime Minister has been emphasizing on a developed India, Viksit Bharat. So how we can utilize our own technologies, indigenous technologies, to make India a developed nation in the world. So that is the theme for this year. Before I go to that, I would like to start with a very humorous slide. Pilamane got a byanga chitra, humorous slide you see here. Now we are so much dependent on science and technology. Flood is coming, severe flood is coming. Two friends are there. One is simply running to escape from the flood. What the other friend is doing, he is taking out his mobile. He is telling that I have an app in my mobile which will stop this flood, so that I can escape myself from the flood. So this is the concept, this is the mindset. On anything and everything, we are now depending on science. I will be giving some examples to you. Scientific facts and fictions. Yesterday's fictions are today's facts. Pilamane kehi ame jetebele tambali pila thilu setebele 50 years back. Nobody thought of such an instrument will be developed in future. जोथरे किछि की को प्रेस कले मोर झियो अमेरिका रे अछि संगे संगे ता सहित कथा ही पारिबे. That was a dream. Now this is the reality. In science, what happens? Yesterday's fictions, what was a fiction? Kalpana thila kali. That is the reality today. We are doing that. And today's fictions will be tomorrow's facts. What you are thinking is an imagination of scientists today. Tomorrow that will be converted into reality. You can see here a dome structure. In future, the scientists are going to develop such a dome structure on the surface of Mars. Mars vision. I will be showing some slides on that. So that some human beings will be making a voyage to Mars, live there for some days, 10-15 days for holidaying, छुट्टी कटेइकरी पुणी आउथरे अर्थ को फेरी आसीबे. Elon Musk, SpaceX company, पिलामन जानिछ, he is the richest person of the world and his company is SpaceX. And they are making a special spacecraft through which people will be moving to Mars in future. That is going to be a reality in few years. And this picture shows Sundar Pichai, you must be knowing. So he is the CEO of Google company. Okay, so that is not important. What is more important? He searched for a personal assistant, जे के तांको कामरे साहाଯ୍य करिवे, PA. How many people are there on earth today? What is the world population? 8 billion, 800 crores, more than that. Okay? He could not find a single person who can work as his personal assistant. Now what you see here on the left side, she is Chloe. Chloe is not a human being, Manisha Nuha, and he is a humanoid robot. So the greatest man of the world, Sundar Pichai, has employed Chloe, who is the humanoid robot, working as his personal assistant. Just imagine. So now you have to compete with robots. Okay? So in future, for your jobs, for everything you do, you have to compete with robots who are very much enriched with artificial intelligence. So you have to think about that. There is a vast robot teacher in the world, Indus International School in Bengaluru. They are having a teacher who is standing here on the right side, Eagle 2.0. She is the robot teacher. On the left side, you can see the robot teacher and the real teacher there inside the class, standing here. I am the teacher here and some robot will be standing here. If you are asking a question to me, I am unable to answer to that. Immediately the robot teacher will answer that. Okay? That is happening at present. That is the reality. Indus International School, Bengaluru. It's very interesting. As I told you, my daughter is staying in USA in Denver city. Last year she was here. ପିଲାମାନେ ଆମେରିକାରୁ ଆସିକି ଭୁବନେଶ୍ୱରରେ ଆମ ଘରେ ରହୁଥିଲା ସମୟରେ ଏ ଯେଉଁ ପିକ୍ଚର ଦେଖୁଛ ଏଇଟା ଆମେରିକାରେ ତା ଘରେ ଯେଉଁ ଫୁଲ କୁଣ୍ଡ ରଖିଥିଲା ତାର ପିକ୍ଚର। ଆଚ୍ଛା ଭୁବନେଶ୍ୱରରେ ବସିକି ଆମେରିକାରେ ଗଛରେ ପାଣି ଦିଆହେଉଛି। କ୍ୟାନ୍ ୟୁ ଇମାଜିନ୍? ଦେଖୁଛ ପିଲାମାନେ ଗଛ ସବୁ ସରୁ ପ୍ଲାଷ୍ଟିକ ପାଇପ୍ରେ କନେକ୍ଟେଡ୍ ହେଇଛି। ସେଠି ଗୋଟେ ଇନଷ୍ଟ୍ରୁମେଣ୍ଟ ଅଛି ସେଠି ଲାଇଟ୍ରେ ଆଉ ଗୋଟେ ପାଣି ଜାଗା ଅଛି ୱାଟର କଣ୍ଟେନର। से जो इंस्ट्रूमेंट रे गोटे आप दिया आप अच्छी आउ सेमानक मोबाइल रे सेम आप अच्छी एठी बसिकी आमे मोबाइल रे आपटा ऑन कले सेठी से आपटा ऑन हो गला। ओके एंड संगे संगे पानी चलिला गछरे पानी दिया हेगला कुंडरे पानी दिया हेगला बुझियला। दिस सेम्स ए स्टोरी बट दैट इज द रियलिटी। एटा ही वास्तवता आज रियलिटी। पृथ्वीर जेकोसी जगार बसिकी ये बसिकी श्री श्री यूनिवर्सिटी अमेरिका रे गछरे पानी दिया हो। कैन यू इमेजिन अबाउट दिस? दिस इज मोर देन ए ड्रीम बट दैट साइंस हैज मेड दिस द रियलिटी। नाउ ट्रैवल टू मून बाय स्पेस बुलेट ट्रेन। फ्यू डेज बैक जापानीज साइंटिस्ट हैव टेकन अप दिस प्रोजेक्ट। से माने काम आरंभ कर देइचंती एमती गोटे स्पेस बुलेट ट्रेन प्रिपेयर करचंती हेक्सागन स्पेस ट्रैक सिस्टम जो थे ग्राविटी सिस्टम को अर्थ रे जेमती ग्राविटी सिस्टम अच्छी सेमती मून पर्यंत डेवलप करा जिवो जो थे गोटे स्पेस शटल विल मूव टू द मून। आउ फ्यूचर रे भी प्लान अच्छी दे विल आल्सो गो टू मार्स। सो मु जहाँ फास्ट रे कहितली व्हाट अपीयर्स ए फिक्शन टुडे इज गोइंग टू बी द फैक्ट टुमारो। So what is science? What we are doing in science, we are unveiling the mysteries of nature. Mysteries in physical world and natural world. Whatever mysteries scientists find, they want to unveil. What is the reality behind that? What is the principle behind that? कौथि पाई ए जिनसटा एमती काम करूची? What, why, how? So they have to find out the answers. So that is science. We have to employ, we have to observe certain things. तमे किसी भी गोटे बाहर देखिलो, you observe certain things. Then next what you are doing, you are questioning yourself. Why is this happening? How is this happening? That is the question that comes to your mind. Next what you are doing, hypothesis. You are making an hypothesis. Most probably this is the reason for which this is happening. Okay? You are making your own hypothesis. Then next step is experimenting. In the laboratory, you are performing certain experiments. Scientists are doing experiments, just like Dr. Biplov. So ultimately, they are getting the results. Experiment pare kon next asigala results. They are making analysis of results and finally conclusion. Whether your hypothesis is wrong or right, now you conclude. Bujhiyala pilamane? This is science. This is how we are experimenting on anything and everything. We are finding out the truth behind that. There are two scientists, two statements by two scientists. One is a great scientist, Alfred Nobel. Janicho samaste pilamane Alfred Nobel? Okay. On whose name Nobel Prize has been established. Beautiful statement, science is in the service of mankind. A great man having a lot of discoveries, inventions, earned a lot of money, instituted Nobel Prize. से किंतु स्टेटमेंट देले ये साइंस रा ऑब्जेक्टिव कौन हवा दरकार? साइंस इज टू सर्व द सोसाइटी, द पीपल, फॉर द बेटरमेंट ऑफ द सोसाइटी, नॉट फॉर डिस्ट्रक्शन, We are having nuclear warfares. Juddha chaluchi, war chaluchi. That is not the objective of science. So science must be contributing positively for the cause of the society to solve the problems of the society. That is the objective. The other statement by Calvin Kelly, another scientist, editor, science is the way we surprise God. जहाँ सब एग्जाम्पल मु साइट कली कैल्विन केली कहउचंती आमे भगवान को भी सरप्राइज कर दउछे वी आर द गॉड मस्ट बी सरप्राइज्ड एट आवर इन्वेंशंस God must be thinking I have created this creature but they have surpassed me taking the shelter of science and technology they are doing anything marvelous things. So, Homo sapiens, we human beings have been blessed with two very beautiful characteristics, exceptional qualities. What are these? We are having the highest level of intelligence and we have been blessed with wisdom also. Intelligence you understand. Okay, what happened in Second World War? Anybody? What destructive thing happened in Second World War? Anybody who can suggest? Yes? Okay, atom bombs, destruction in Hiroshima and Nagasaki of Japan. Okay, we applied our intelligence. Did we apply our wisdom? Wisdom buchcho ki nahi pila mane? What is wrong and what is right? That decision you have to take. That was right or wrong? Applying atom bomb in Japan, whether that was right or wrong? That was a completely blunder on the part of the humanity. So their science failed. We applied our intelligence, but we did not apply our wisdom. So that's why in science we are supposed to apply wisdom. Along with intelligence, we have to also apply wisdom so that only good things happen, nothing destructive. So scientists are very much curiosity driven, they think differently. Left picture you see, who is that? Newton. समस्ते तो गच्छ मूल बसुंच एप्पल पड़ुची किंतु समस्ते न्यूटन को भलिया भाबु नाहंती लॉज ऑफ मोशन बिकॉज साइंटिस्ट थिंक differently than others. That's why they discovered so many things, they invent so many things. On the right side, the great scientist Charles Darwin, evolution theory. पढ़ुछ टिके पिला माने? So he was in Galapagos Island. Said देखिले so many types of birds, hundreds of different birds. एका भलिया दूर देखा जाउछंती. But he was very much curiosity driven. कहले कौन होची समस्त closely observe कले देखिले समस्तंगर big structure. टिके टिके अलगा अछि. किए fruits खाउची, किए flower खाउची, किए seeds खाउची, किए worms, insects खाउची, अलगा अलगा food habit. So that he could observe. तापर समय रे से evolution theory, natural selection theory suggest करथिले जहाँ तमे पढुछ टिके टिके. So they are very much different in their thinking process. They are curiosity driven. And scientists' excitement, Archimedes story. पिला माने सब पढ़िछ जानिछ एटा Archimedes story. राजा तांको कहिले जो क्राउन मुकुट सुनार तयारी हेछि ता भितरे किछि खाद्य अछि कि. You have to find out whether that is 100% gold or not. Okay. So he was thinking over that. सबुळे तांको माइंड रे सही एक्साइटमेंट रही how to find out the answer to this. And once he was taking his bath in the bathroom, देखुछ पिला माने पिक्चर अछि. He could find out the answer. Okay? कोन भाबिले प्रिंसिपल ऑफ बाउंस. पानी रे केमति भासीबा से प्रिंसिपल तांको माइंड को स्ट्राइक कला. और सेही कंडीशन रे in naked condition he started running on the road to the king. Eureka, Eureka. You see, this is the excitement of scientists. How much devoted, how much dedicated they are to find out the cause behind that. Imagination of a poet is beautiful. पिला माने बहुत कविता पढ़ुछ पोएम्स यू आर रीडिंग अनेक कवि लिखिसंती जे चंद्रर सौंदर्य ब्यूटी ऑफ मून इज has been explained in different ways. So much beautiful the moon is. But what happened in 1969 when Neil Armstrong and his friends Collins and Aldrin, they went to the surface of moon. They could find only barren lands, deserts, nothing else. No life, no oxygen, no water, nothing there. जो कविता सब पढ़ी थिले इन लेफ्ट रे गोटे लाइन लिखा इज द मून हियर्स द टच ऑफ माय ब्रीथ मु एठु निश्वास नेला बेलू को चंद्र सेठी अनुभव करूची ए प्रकार कविता जो पढ़ी थिले सेते बेले नील आर्मस्ट्रंग देखिले काहे सौंदर्य व्हाट इज द ब्यूटी ऑफ मून एवरीवेयर डेजर्ट एंड डेजर्ट ता पूर्वरु एक कथा जेते बेले पृथ्वीवासी को कहिले समस्त को ता परठु बापा माँ माने झियो ना चंद्रमुखी दबा बंद कर देइछन चंद्रर सौंदर्य कथा कौन जो वर्णना कले से मु लिखिली द इमेजिनेशन ऑफ ए पोएट इज ब्यूटीफुल बट द इमेजिनेशन ऑफ ए साइंटिस्ट इज मोर ब्यूटीफुल व्हाट इज द रियलिटी रियल पिक्चर दैट इज बीइंग गिवन बाय द साइंटिस्ट advancements of science and technology robotic hands touching the human hand now robots as well as humans they are working together so that our working efficiency is increasing. So human beings are always trying to increase their efficiency. So with the own creation, robots have been created by us together. Humans and robots, they are working. But science has limitations. Science cannot do anything and everything. Whatever you tell, because science is based on evidences, proof. Without any evidence, if you ask a question, very common question, existence of God, whether the God exists or not, if that is the question, what will be your answer? Anybody? Whether God is existing or not, what is the answer of science to that? No, science cannot deny or science cannot tell, yes, God is there. Science cannot tell that God is not there. What we cannot prove, we cannot answer to that. What we are proving in science, we are explaining that. Okay, clear? So controversies like this should be avoided. So there are many frontiers of science. In 21st century, a lot of research is being conducted in various fields. Just now he explained a very beautiful research work, what he has done. Like that, these are some important frontiers: nanotechnology, communication and information technology, genetic engineering, biotechnology, exobiology, environmental science. These are some of the very important areas, magic of nanotechnology. Some scientists, they are claiming they have developed a powder-like structure. पिलामाने right रे जो देखुचे जने chair रे बसन तांको face is not visible. देखा होनी मुह से गोटे powder लगे देइछंती तांको केही देख परिबे नाही. तमाने समस्त भितर इच्छा अच्छी एमती किसी पॉसिबल होता कि मत कहीं देखिपारे ना मु किंतु समस्त को देखिपारि ताहले जिते भल भल खाइबा मीठा दुकान अच्छी पशिब आराम रे खाई बाहरी आसो कहीं देखिपारे भल ड्रेस दुकान भितर पशिब जिते सब कॉस्टली ड्रेस सुंदर सुंदर ड्रेस धरिकी पलि आसो सेटा बर्तमान साइंटिस्ट माने रियलिटी को ट्रांसलेट करुछंती. दिस इज द मैजिक ऑफ नैनो टेक्नोलॉजी. इनविजिबल मैन can be developed if you are applying some chemicals on your body. Nobody will be able to see you, but you can see others and you can do whatever you wish. So, tame bhabuthuva eguda ko sabu imagination. No. You see, communication, earth has become one family right now. The example mu कहली मोबाइल रे बर्तन चाहिए पृथ्वी रे जेकोसी कर्ण रे जे भी अच्छे ता सहित आमे वीडियो चैट करि पारछे. कम्युनिकेशन टेक्नोलॉजी हैज डेवलप्ड लाइक एनीथिंग. वेयरेबल टेक्नोलॉजीज भास्ट एप्लीकेशंस. हाथ रे गोटे घंटा भले आमे बांधी दउछे सेथिरे मोर ब्लड प्रेशर केते अछि, सुगर केते, मोर पल्स रेट केते, एवरीथिंग आस जाउ संग संग डिजिटल. ओके. So wearable technology like this बहुत उड़े pacemakers आजकल सब remote रे हमें use करचे everything in remote, even remote रे fan चल रही बहुत कथा डेवलप है सो वेयरेबल टेक्नोलोजी हाथ में बांधिक देह यूज करी आम ये सब हेल्प कर जीपीएस ट्रैकर आजिकल जो मैंने एज हो जाऊँगी से भूली जाऊँ जिनस कौट रखुंट जीपीएस ट्रैकर रे कौन करा ने तुम फीड करदेव तुम घंटाटा कौ जगह मोबाइलटा कौटे अच्छी अन्य कौ जिनस कौटे रखीच घरे से फीड करदे जो खोजा दरकार ना से तुमको इंडिकेशन मिल जाए जगह तुम से जिनस थुआ जीपीएस ट्रैकर इन 2007 आई वाज इन अटलांटा यूनिवर्सिटी यूएसए मत जड़े प्रोफेसर को मीट करवा यूनिवर्सिटी पहुँचला प्रोफेसर को चैम्बर ताला लगी मुझे खोजिली कौटी पाऊनी आउ जन वेरी सीनियर प्रोफेसर आसिले मत हेल्प कले कहले आसतु मो सांगे मुझे पछे पछे गली से अमेरिका जीपीएस ट्रैकर डेवलप हो सारी से यूज कर तो से प्रोफेसर तांको फोन नंबर को लगेले से कौ जगार कैंपस रे अच्छी से फॉलो करके जाइए पहुँची गले बुझिपारे कि नहीं मुझे पहुँची गली सांगे आई कुड नॉट थिंक एट दैट टाइम जे एतिक डेवलप टेक्नोलॉजी है सो जीपीएस ट्रैकर बर्तमान बहुत यूज होमें सब कथार सो व्हाट हैज हैपेंड साइंस एंड टेक्नोलॉजी डिपेंडेंट डायरेक्टेड डेवलपमेंट एंड लाइफ आम जहाँ करुचे सबुथरे there is application of science and technology. Without science and technology we cannot pass a single day, we cannot do any sort of work. So everything controlled by science and technology. Heartbeat कार हार्ट खराब होची एबे स्टैनफोर्ड यूनिवर्सिटी रो साइंटिस्ट माने डेवलप कर लाइट जोटा लाइट हार्ट रे पकेले नॉर्मल हो जिवो कार हार्ट बीट अधिक होथबो कार कम होथबो नॉर्मल हार्ट रेट हबो इवन गोटे नानो रोबोट डेवलप है कहार पेस मेकर खराब हेले हार्ट पाखरे ताकू फिट कर दिया होची नॉर्मल हार्ट रेट पेस मेकर ठीक भाव रे फंक्शन करुची दिस इज टुडेज रियलिटी एक कथा मध्य नानो रोबोट रिसर्च रे आसिलानी जे आम ब्लड रे नानो रोबोट को छाड़ दिया जीवो आम बॉडी भीतर कैंसर सेल्स डेवलप होउचंती की से माने खोजी खोजी केवल कैंसर सेल को डिस्ट्रॉय करिवे नॉर्मल सेल्स इंटैक्ट रहिबे बुझ पारछो नानो रोबोट्स विल किल कैंसर सेल्स इनसाइड आवर बॉडी सो दैट इज द रिसर्च गोइंग ऑन एंड स्टेम सेल रिसर्च एबे किछि साइंटिस्ट कहउछन आमे टिके अधिक वर्ष बंचिबा लाइफ स्पान लंगजिविटी बढ़ाई दिया हबो 200 वर्ष बंचिबो पॉपुलेशन 800 कोटी क्रॉस करी गलानी 2050 मसिया बळकु वर्ल्ड पॉपुलेशन 1000 करोड़ हबो तथापि किछि साइंटिस्ट कहउछन आमे टिके अधिक वर्ष बंचिबा तेणु केमिथि आमे ओल्ड हबा ना यंग हेकि थिबा तापर रिसर्च चलीछि किछि साइंटिफिक फाइंडिंग्स आसीछि एनएडी लेवल आम बॉडी रे जदि मेंटेन कराहबो हाई लेवल रे रखाहबो ताहले जणे यंग हेकि रहिबो तार लाइफ स्पान अधिक हो जिवो तापर काम चलीछि एवं आखि जनकर खराब हो गला बर्तमान स्टेम सेल रिसर्च रे बहुत डेवलपमेंट होछि आखि रे जो कौन सेल्स आम रेटिना रे अच्छी से कौन सेल्स को आउ थे रिप्लांट करी स्टेम सेल यूज रे पुणी नॉर्मल कर दिया गला जहाँ को देखा जाऊ नथिला नाउ ही कैन सी लाइक ए नॉर्मल ह्यूमन बीइंग सो क्लोनिंग होची मंकी रो क्लोनिंग होची विशेष करी चाइना रे जो लैबोरेटरी एक्सपेरिमेंट्स बहुत मंकीज ऊपर होची तनु क्लोनिंग माध्यम रे करचंती एंड सरोगेसी पिला माने एटा तो समस्त जानि छ सब तमरो फेवरेट हीरोइन हु इज दैट प्रियंका चोपड़ा तार रिसेंटली फ्यू इयर्स बैक तार जो चाइल्ड हेची दैट वाज बाय द प्रोसेस ऑफ सरोगेसी she has not delivered that child somebody else से लिखा है her body my baby growing inside her body so that is the new concept how the things are changing आ गोटे बहुत सुंदर डेवलपमेंट एबे हेछि आर्टिफिशियल वुम्स लैबोरेटरी भितरे पिला माने आगु को जन्म हेबे मार womb भितरे नो not inside wombs of mother inside laboratory artificial wombs are being developed in the laboratories so पिला माने आगु को laboratory जन्म हेबे माँ मान को कष्ट करिया को पड़िबो नहीं ऑलरेडी एक्सपेरिमेंटेशन सक्सेस आड़ को जाउची जो पिक्चर देखुछो जापानीज एंड अमेरिकन साइंटिस्ट से माने ऑलरेडी परफॉर्म कर सलेनी गोट एग्जांपल डेवलपमेंट बहुत लेटेस्ट स्टेज पर्यंत कंप्लीट हो सारी आगु को कंप्लीटली 100% सक्सेसफुल होबा को जाउछि सो दिस इज हाउ साइंस इज डेवलपिंग जेनेटिक इंजीनियरिंग बायोटेक्नोलॉजी A very promising field, cloning hochi, stem cell research, recombinant DNA, designer babies, genetically modified crops, so many things are there. Stem cells रे scientists माने वर्तमान भाबुचंती जे आगो को laboratory रे सबु organ तैयारी हबो. तमे वर्तमान किडनी कहार खराब हे गले पिला माने जानुचो किडनी डोनेशन होची. Okay, दीटा किडनी अच्छी, one can donate one kidney. But तम पाखरे गोटी हार्ट अच्छी, you cannot donate somebody else. अन्य कहार हार्ट खराब हे गले आमे कोन हार्ट दे परिवा नहीं. सेमते एक्सीडेंट रे कहार हाथ गोड़ कटि जाउची. सो आगो को ए सब ऑर्गन्स लैबोरेटरी डेवलप हबो फ्रॉम स्टेम सेल्स. तेणु जहार जेते बेले कोनोसी ऑर्गन इंटरनल ऑर्गन खराब होची से लैबोरेटरी साइंटिस्ट मानक पाहु गले पुणी आउथरे न्यू ऑर्गन विल बी प्लांटेड इनसाइड द body. So this is the research that is going on. Genetic engineering, biotechnology, transgenic organisms, cloning, transgenic organisms. Sheep cloning agur hei sarchi pila mane padhi thibo kichi kichi. Acha. So human cloning ko ban kara jaichi because there are a lot of problems are there. Human cloning has been banned globally. And transgenic organisms, said a reality no, that's a fiction. सेमती कि नहांती मनीष मुंड थाई चढ़ई बॉडी अच्छी नॉट लाइक दैट बट फिक्शंस आर गेटिंग ट्रांसलेटेड इनटू रियलिटी इन साइंस सो इन फ्यूचर प्लांट केस रे बहुत केस हे साराणी अच्छा वेरी इंटरेस्टिंग एग्जांपल डिजाइनर बेबीज एबे साइंटिस्ट माने कहउचंते आगो को आमे सब डिजाइनर बेबी तैयारी करबा केमती ना आफ्टर मैरेज हला पर हस्बैंड वाइफ दी जन गोटे लिस्ट नहीं कि पिला माने जाइछंती साइंटिस्ट मानक पाखको सो दैट लिस्ट इज मेंशन देयर तांको गोटे झियो पिला दरकार कलर मस्ट बी व्हाइट एंड हाइट मस्ट बी टॉल 6 फीट 2 इंचेस तापर हेयर स्ट्रेटन हेथिवा दरकार आ ब्यूटी पार्लर को जिबा दरकार नहीं स्ट्रेटनिंग करिया पई जन्मरु तार स्ट्रेटनिंग हेथिबो आईज ब्लू हेथिबो ऐश्वर्या राय भलिया तेन ब्लू आइड आउ तार बॉडी स्लिम हेथिबो सो दैट फ्यूचर रे शी विल बी अ ब्यूटी क्वीन मिस यूनिवर्स और मिस वर्ल्ड लाइक दैट सो एई भलिया गोटे लिस्ट नै करी साइंटिस्ट माने जिबे साइंटिस्ट के पाखकू पेरेंट्स जिबे आउ आइडेंटिफाइड जीन्स से सब जीन को साइंटिस्ट माने आइडेंटिफाई करथिबे से जीन सब तांकर वुड बी पिला ता भीतर इंसर्ट करा हबो फ्यूचर रे एई कैरेक्टरिस्टिक हेकरी से भलिया पिला जन्म हबो ताको आमे कोन कहूचे डिजाइनर बेबीज सो बायो इंजीनियर्ड बेबीज आगु को एई भलिया सब लैबोरेटरी पिला जन्म हबे ता भीतर सुपर ह्यूमन बीइंग्स कथा वर्तमान आलोचना चली एमती कि होंता किछि जीन आम बॉडी रे इंसर्ट करा जानता आमको कोनोसी रोग हबो नाही डिजीज फ्री एमती होंता ब्रेन रे सबुठु इंटेलिजेंट जीन इंसर्ट कर दिया जानता सब जहाँ थरे पढ़िबो सब मन रही गला आउ सेकेंड टाइम पढ़िबा दरकार नहीं परीक्षा रे 100 रो 100 ए सब क्वालिटी केमती डेवलप हबो सुपर ह्यूमन बीइंग्स ता ऊपर रिसर्च चली वर्तमान आगु को एमती हे पारे डिजाइनर बेबी सब लैबोरेटरी थिबे ए पेरेंट्स जाइचंदी खोजिया पाई काहार गोटे टेक टाइकुन दरकार काहार बहुत भलो तेंदुलकर भलिया एथलेट दरकार काहार म्यूजिक जीनियस लता मंगेशकर भलिया दरकार काहाकू कार्टूनिस्ट भलो दरकार भलो डॉक्टर दरकार सो मेनी ऑप्शंस आर देयर सब लैबोरेटरी एमती पिला डेवलप करा हबो पेरेंट्स जिबे से तांकर चॉइस अनुसार सिलेक्ट करिग्रे कलेक्ट करेंगे तमें ए गुटाक स्टोरी भावुव बर्तमान किंतु रियलिटी देख ये प्रोफेसर अमरेंद्र मिश्र अच्छा जी कि सब कम कर जेनेटिकली मॉडिफाइड क्रॉप्स जेनेटिकली मॉडिफाइड फूड्स ये सब अच्छी बर्तमान बीटी कॉटन बीटी टमाटो बीटी ब्रिंजल बीटी कॉर्न ये जो टमाटो पिला माने देखुच आजिकल मार्केट रो आणुचे आमे यूज करछे 50 इयर्स बैक आमे जेतले पिला थिलु एउडा नथिला किछि आमे जो टमाटो सेते बेले खाउथलु सो बंका तेढ़ा एमती राउंड सर्कल टमाटो वाज नॉट देयर एते फ्लेसी टमाटो वाज नॉट देयर दीज आर क्रिएशंस ऑफ साइंटिस्ट माने जेनेटिक मॉडिफिकेशन करी जीन ने परिवर्तन करी वेराइटीज ऑफ ऑल दिस ये जो बीटी बैसिलस थुरिंजिएंसिस जो बैक्टीरियम रु जीन आइडेंटिफाई करी ताकू अन्य प्लांट रे इंसर्ट करा जाइछि से जीन जो इनसेक्ट से गछ को खाइबो से मरीजिबो आ पेस्टिसाइड स्प्रे करबा दरकार नहीं ए उद्देश्य रे ए सब जो जेनेटिक मॉडिफिकेशन करा जाउछि आगु को एकथा मध्य प्लांट साइंटिस्ट मान ऑब्जेक्टिव अच्छी रोग केमती गछ को न हब कम पानी रे प्रोडक्शन हब कम ड्यूरेशन रे प्रोडक्शन हब ये सब क्वालिटी को इंसर्ट करी बहुत फूड प्रोडक्शन को एनहांस करेंगे आउ आमर फूड सिक्योरिटी एनश्योर हब किछि साइंटिस्ट कहउछंती अच्छा जदि गछटा सबुज होइछि द प्लांट्स आर ग्रीन सो दैट दे आर हैविंग फोटोसिंथेसिस आम बॉडी भितर गोटे ग्रीन क्लोरोफिल जीन को इंसर्ट करदेले आम समस्ते सबुज देखा हबा आ अध घंटे जाइकरी खराड छिड़ा हो फोटोसिंथेसिस हो किछि परिश्रम करिया दरकार नहीं आम बॉडी भितर फूड तैयारी हो हाँ कि नहीं अरे तुम बॉडी जदि सबुज हो ग्रीन हो ताहले क्लोरोफिल आम बॉडी भितर जदि हो ताहले आम खरारे अध घंटे छिड़ा हबा सो दैट फोटोसिंथेसिस हब ऑटोमेटिकली फूड प्रोडक्शन हो इनसाइड बॉडी सो दैट इज द थिंकिंग ऑफ सम सिंथेटिक बायोलॉजी सम साइंटिस्ट से माने कहउछंती आमे निजे लैबोरेटरी रे लाइफ क्रिएट करिवा गोटे ऑलरेडी काम हो सारी माइकोप्लाज्मा माइकोडेस उपरे लैबोरेटरी साइंटिस्ट माने डीएनए प्रिपेरेसन तार कर सारी आगु को आहरी बहुत काम हवा को अच्छी साइबर वेयर वेरी प्रॉमिसिंग फील्ड अच्छा ये जो पिला साइंटिस्ट देखु तले सी किए स्टीफन हॉकिंग अच्छा वेरी नाइस स्टीफन हॉकिंग वाज ए ब्रिलियंट साइंटिस्ट किंतु ही वाज पैरालाइज्ड फ्रॉम अर्ली एज तेणु तांकर गोटे सुपर कंप्यूटर सहित तांको ब्रेन को कनेक्ट कराइला जहाँ से भावुले सब ट्रांसलेट होता कंप्यूटर को सो तांकर जहाँ आइडिया सब अन्य माने केमी जानूले फ्रॉम दैट कंप्यूटर एबे तुम पाई खुशी खबर ऑलरेडी एक्सपेरिमेंट हो सारा ए स्मॉल चिप इज बीइंग डेवलप्ड स्मॉल कंप्यूटर चिप अच्छा से कंप्यूटर चिप रे कौन हम पिला माने तमरो सब बही रखी दिया हम all the textbooks okay in that computer chip and that computer chip will be inserted into a at the दिन तले experiment ही साल रहने already computer chip will be inserted into the brain सहित connect कर दिया गला तमे आ पाठ किछि पढ़िबा दरकार नै सब जाक सहित अछि straight away go to the examination hall and all the questions in the question paper you are answering very effectively getting 100 out of 100 okay so this is going to be the reality very shortly already experimentation has been done not this one not that examination hall you will be cheating like this but many other things are going to happen in this field artificial intelligence the picture you see Sophia she is moving throughout the world humanoid robot and for the first time a robot has been given citizenship by Saudi Arabia, not a human being, a robot having been given citizenship by Saudi Arabia. And she is very much intelligent. She is moving to different parts. She was in Bombay IIT. एमती स्टेज छिड़ा है सोफिया जमती छिड़ा है जड़े प्रोफेसर क्वेश्चन कर आंसर सब पिला क्वेश्चन को आंसर कर हसुँच कांदुंट फेसियल एक्सप्रेशन सब प्रकार हो So this is the reality today. Artificial intelligence is applied in all fields. Agoku our whole life will be regulated by artificial intelligence. Very interesting humorous slide पिलामाने जने डॉक्टर लैबोरेटरी ऑपरेशन थिएटर रे ऑपरेशन पेशेंट को करचंती पिलामाने देखो पिक्चर हाफ वे अधा ऑपरेशन कर सल्ला परे ही वाज कंफ्यूज्ड नेक्स्ट व्हाट टू डू से संगे संगे पचार नर्स को कहते जे यू गो टू surgery.com and ask the question what step I have to do next. Okay, so this explains to what extent we are depending on science and technology today. So energy is another serious problem. Global warming, climate change पिला माने पढ़ुछो ता रूट रे अच्छी एनर्जी बर्तमान हमको ग्रीन एनर्जी अल्टरनेट सोर्सेस ऑफ एनर्जी विषय करिया पड़ो इलेक्ट्रिक व्हीकल्स आर रनिंग आर फ्लाइंग इन ऑल सिटीज आगु केवल इलेक्ट्रिक व्हीकल्स ही काम करिवो सो देयर इज रिवोल्यूशनरी चेंज इन द लाइफस्टाइल्स हम समस्त दीटा को कंपेयर कर गोटे ट्राइबल फैमिली लिविंग इनसाइड ए फॉरेस्ट एंड द मॉडर्न गर्ल लिविंग द अल्ट्रा मॉडर्न लाइफस्टाइल ये सब कहा जगह है all these transformations due to science and technology. So we have to understand what sort of changes. Some scientists, they are telling that we are satisfied whatever they are on earth. पृथ्वी रे जहाँ अच्छी आमे सब देख सारे सब जानी सारे. We want to explore beyond earth, exobiology. जोटा कि वर्तमान रिसर्च मार्स उपरे होची, मून उपरे होची, other planets उपरे होची. Elon Musk again. So in future we are going to build a cone-like structure on the surface of Mars. जोठू आमरो एठू अर्थ रु जो लोक माने मार्स को जिबे से डोम भितर रहिबे किंतु सेठी बंचिबा पई ऑक्सीजन एठू नै कि जिबा को पड़िबो फूड एठू नै कि जिबा को पड़िबो जहा जहा रिक्वायरमेंट सब अर्थ रु नै कि जिबा पड़िबो केवल एनर्जी सेठी अवेलेबल हबो सोलर एनर्जी विल बी देयर we can utilize that solar energy but other things we have to carry. But on the other hand, what is happening to our own planet, any second planet, any planet B where living organisms are present, any idea? Anywhere in the universe? तम पाखरे किछि आइडिया अछि जे अन्य कोठी लाइफ एग्जिस्ट करूछि यूनिवर्स रे? No, there is no idea. No second planet, no planet B. This is the only planet where we are living. We have to save this planet. What we are doing? We are so much engrossed with science and technology, we are forgetting about our own environment, nature. We are making a lot of destructive works. Brown environmental issues. ये जहाँ सब लिखा है, overconsumption by developed countries, overpopulation in developing poor countries, सेमानक पाखरे population अधिक. Rich countries, सेमानक पाखरे wealth अधिक, सेमान अधिक खर्च करुछन्ति. Pollution of all sorts, greenhouse gases, global warming, climate change, ozone depletion, toxic chemicals released into environment, waste disposal is a big problem, soil erosion, loss of biodiversity, like this. A number of serious environmental challenges are confronting us. Gote side re science and technology ko use karikri, we are creating marvels. On the other side, we are destroying our mother nature. One very important scientist told a statement. He told man is a very mad creature. Why? We are the most intelligent creature. He told that man is worshipping an invisible God. Adrusya Bhagavan ko manisha puja karuchi, but destroying a visible nature. दृश्यमान होथुवा प्रकृति को नष्ट भ्रष्ट करुछि मनुष्य. Without knowing that the invisible God he is worshipping is the visible nature he is destroying. आमे जानिबार सक्षम होना है जो अदृश्य भगवान को आमे पूजा करुछे वास्तविक रियलिटी रे से होछि जो विजिबल बा दृश्यमान होतबा प्रकृति आम चारिपटे रहिछि आमको खाइबा को दउछि सब किछि दउछि. So प्रकृति को पूजा करिबा, that must be our objective. Science and technology रे development बहुत होछि ठीक अछि for the betterment of humanity, betterment of the earth. Simultaneously आमे देखिबा दरकार we should not create anything that destroys the nature of earth, our planet. So that is our primary responsibility. So population is increasing and resources are depleting. सब resource deplete ही चलछि कमी कमी आछि. आगु को सरी जीव परवर्ती generation जो माने आसीबे future generations, what they will be using. We have to think about that. Mother Earth is crying for help. So एस juncture रे ए time रे जो devastation चलछि global warming, climate change, जो बढ़िया कहा जाउछि साइंटिस्ट मान के प्रेडिक्शन बाय द एंड ऑफ 21st century all the living organisms will disappear from earth, they will become extinct from earth if temperature increase in the temperature is not controlled by reducing greenhouse gases. So emerging diseases, new diseases like COVID are coming, and science has to protect the environmental health of environment. If environment is having good health, then we can also live with good health. That we have to think about. Science and wisdom, the nuclear holocaust, Japan example I discussed. Bio weapons should not be created for destruction of humanity. Science has to work for eradication of superstitions. And science has to solve the human sufferings. ए जो लोगों को पिक्चर पिलावन देखुचे से माने खाइबा को पाउनाहंती पीबा को पाउनाहंती से मानकर problems must be solved by scientific research, science and technology. Mass extinction may happen in future. आगो को बहुत एई भलिया species सब extinct ही जाई पारंती due to negative impacts of human activities. So we have to think seriously about all these happenings. We have to fight against pseudoscience, false science. अनेक लोक अछंती जे तम घर आगे घरे गोटे फेंग सुई कर देले तमर सब भल हो जो पॉजिटिव एनर्जी भर्ती हो जो. I don't find any science behind this. Healing crystals किछि क्रिस्टल लगे देले तमर सब जिंस healing हो जो परीक्षा रे टॉपर हो जो. There is no science behind this. We should not accept anything which is not based on evidences. Okay? We have to find the reason. Now coming to this year's Developed India, Viksit Bharat, our priority must be to have indigenous technologies. I mean, nije kono. Bartaman dita word pila mane man rakho. Very vital. One is skill, the other is innovation. If suppose a room re electricity chali gala, fuse chali gala. तमे भितर केही फ्यूज बंधा शिखिच कहीं शिखना फ्यूज चली गले फ्यूज वायर केमती बांधी दे हबो नो स्किल मार्केट वैल्यू जीरो सो यू हैव टू डेवलप स्किल जेते अधिक स्किलफुल हबो मार्केट वैल्यू तमर सेते अधिक हबो स्किल इज ए मस्ट ओके गवर्नमेंट ऑफ इंडिया गवर्नमेंट ऑफ ओडिशा सो स्किल रे ट्रेनिंग बहुत लोक दउचंती वर्तमान ओके ट्रेनिंग इज बीइंग प्रोवाइडेड वेरियस aspects of skill development. Second is innovation. बहुत पाठ पढ़ल ओके जॉब कल जेकोस फील्ड रे जदि किछि नुआ करिवार माइंडसेट नाही न्यू थिंकिंग देन यू आर रिजेक्टेड इन द सिस्टम सब बेले थिंक डिफरेंटली फ्रॉम अदर्स अन्य माने जहा नॉर्मल जिंस भाबुचंती बियॉन्ड दैट यू हैव टू थिंक ओके so that you can create new things, innovate new things. So skill and innovation are very vital at the present juncture. You must remember these two words and work accordingly. So Viksit Bharat India re बहुत development बर्तन INS Vikrant develop है completely new indigenous technology रे आमर own technology रे कोवैक्सीन पिला माने कोविड पीरियड रे सब देखि छ केमती वैक्सीन पय हम माने केते व्यस्त होतले कोवैक्सीन भारत बायोटेक से बळे अनेक गुडे वैक्सीन वर्तमान इंडिया रे indigenously develop helani. Our voyage to moon, to Mars, Chandrayaan, Mangalyaan, इत्यादि इत्यादि बहुत कथा वर्तमान इंडियन साइंटिस्ट आमर ऑब्जेक्टिव होची जे इंडिजिनस इनोवेशंस को आमे इंडियन साइंटिस्ट मानक द्वारा काम करिकरी ग्लोबली केते निजु को अधिक डेवलप करि परिबा ग्लोबल पीपल दे विल थिंक अबाउट इंडियन साइंटिस्ट. सो गोटे डेवलप्ड नेशन हवा पाई आम साइंटिफिक कंट्रीब्यूशन बहुत अधिक हवा दरकार इंडिजिनस निजर टेक्नोलॉजी. सो दिस इज अबाउट कोवैक्सीन. वी आर कमिंग टू एंड ऑफ द प्रेजेंटेशन. पिला माने एटा बढ़िया इंटरेस्टिंग ह्यूमरस स्लाइड देख इथरे अर्थ आउ सैटर्न पाखापाखि अछंती दे आर मेकिंग ए गॉसिप कथावार्ता होचंती. व्हाट सैटर्न सैटर्न शनि का ना सुनले पिला माने समस्त डर अछि कि नहीं काले शनि जसा पड़ी जीवो. वी आर वेरी मच वी हैव मच फियर फॉर सैटर्न ओके किंतु शनि एठी कोन कहउचंती अर्थ को आई एम अफ्रेड ऑफ यू तते देखले मते डर लागुचे अर्थ काहे कि ना यू हैव फॉर एराटिक ह्यूमन बिहेवियर यू हैव ए स्पीसीज कॉल्ड होमो सेपियंस ह्यूमन बीइंग्स who are creating a lot of nuisances on you. काले से माने मो देह को पळे आसीबे मो पाई प्रॉब्लम क्रिएट करिवे दैट्स व्हाई आई एम अफ्रेड ऑफ यू. So this is a $1 million question that you have to think. What this is animal is telling, earth was created for all life, not just for human life. We have to think about all life forms. अन्य समस्त बंचिबा दरकार पृथ्वी रे तांको सहित मनुष्य समान है कि बंचिबो. We have to protect the beauty of mother nature. केडे सुंदर देखा होची thousands of beautiful butterflies sitting on a tree, you will be stranded there. Seti ghantae dhariki chhida hoiki tar beauty ku enjoy karibo. We have to protect mother nature. Ame science and technology ku use kariba. Three important components: government is there, scientists are there, people are there. ସେମାନଙ୍କ ଭିତରେ ଯେତେବେଳେ ଗଭର୍ଣ୍ଣମେଣ୍ଟ କ'ଣ କରୁଛି, ରୁଲ୍ସ ରେଗୁଲେସନ୍ସ ଆଡମିନିଷ୍ଟ୍ରେସନ୍, ଓକେ, ଲୋକମାନଙ୍କର କାମ କ'ଣ, ଆଇନକୁ ମାନିବା ଦରକାର. They have to obey all the rules, regulations. And what the scientists have to do, they have to find out solutions to our problems. Okay? ये तीन जनकर combination ଯେତେବେଳେ best combination हबा, then all the problems will be solved. Science and technology, as Alfred Nobel has given the statement, they should work for the betterment of human society. We live in a beautiful world, and next generations who will be coming to earth, so they will be giving the statement that our ancestors were very good, not very bad. Okay? भविष्य जो मैंने अर्थ को आसवे कहे आम आंसेस्टर्स माने बहुत भल थिले, सुंदर अर्थ गोटे आम छाड़िकी जाइछंती. किंतु शेष रिक्वेस्ट पिलावन, थैंक यू वेरी मच फॉर योर पेशेंट हियरिंग, बट आई हैव ए स्पेशल रिक्वेस्ट फॉर द स्टूडेंट्स, प्लीज मेक ए डिफरेंस इन योर लाइफ. किछि टिके अलगा हवा को चेष्टा कर. जो फील्ड रे तमर एफिशिएंसी अच्छी निजको निजे पछार मु को फील्ड रे भल करि परिबी से फील्ड को चूज कर, काम कर, आगु को जीव. रास्ता रे गला बेले अन्य माने कहिबे दिस इज द बॉय और दिस इज द गर्ल हु हैज डन दिस ट्रेमेंडस वर्क. गॉड ब्लेस यू ऑल. थैंक यू वेरी मच. थैंक यू सर. It was a nice experience talking to you. If anybody has any query or questions, you can please ask. Thank you.
Hello. Thank you, sir. Thank you so much. Now I request our chief guest, Professor Dr. B.R. Sharma, Honorable Vice Chancellor of our university, to come to the dais and say something. Thank you.
Namaste and good morning to all of you. So, today's chief speaker, Dr. Panigrahi ji, and the scientist Biplab ji, our Dean of Faculty of Science, my colleagues, and my dear student friends. I think because nowadays this is a scientific study, it says that only 40 seconds you can focus. But we are sitting here right from the 10 and now it is about to 12. So I think whatever you have heard, I think I should congratulate our FOS Faculty of Science, particularly Dr. Amarendra Mishra ji and his colleagues for thinking of inviting such a scientists who are working in this field for the last many years, and the presentation which they have given, I think it is giving you the each and every aspect of science which is going on today. Each one of us having that impulse to know something, what is happening around me. And Professor has rightly said that unless we develop that kind of awareness, observation, I think we will not be able to mark anything. Therefore, there is a need to develop that kind of attitude, that kind of what you call the visibility, that kind of idea, that kind of observation that may keep you different than that of others. You will be able to think out of the box only when you have that kind of, because impulse, every one of us is having that impulse. But you have to develop that kind of attitude to observe the things out of the box. So this is what he has rightly said, and I was remembering the saying of Vinoba Bhave, who has rightly said long back that ये जो प्रगति है ये अंधी प्रगति है. Whatever is happening in the science today, it is a blind. हिरोशिमा नागासाकी का एग्जाम्पल आया था. ये विवेकहीन है ये प्रगति. That is what he said. Professor has rightly said, Panigrahi ji, that unless there is a wisdom behind this scientific investigations, no use of that kind of scientific facts. Therefore, there is a need to understand this, and this wisdom, as you have seen that we are distorting the mother nature. Today, what we are doing in the agriculture field, now we are turning towards the natural farming and other things. We are now worrying about the health of the soil, you know. Today, we have started thinking this. Slowly. Therefore, there is a need to go for the indigenous technologies, rightly said by Professor Panigrahi ji and Professor Biplav ji. But this can be done only, my dear students, आप लोगों ने अपने आप को, वो मुझे भी दे देना माइक भैया, अपने आप को ऐसा तैयार करना है, आपने अपने आप को ऐसा तैयार करना है कि आपको ये सोचना है, बहुत सारी बातें, ये मैंने अगर मैं थोड़ा सा वो शुरू से अगर मैं बात करूं, तो दोनों साइंटिस्ट ने पूरी हिस्ट्री बता दी आपको. ये क्यों हिस्ट्री बताई है? ताकि आप में वो मोटिवेशन आए, क्या चल रहा है. और अभी in spite of this advancements in the technology and in the science field, we all are losing our access of balance and harmony at all level. Are you agree with this? ये सब होने के बावजूद भी क्यों हम अपना बैलेंस खोए जा रहे हैं, चाहे वो हेल्थ का फील्ड हो, चाहे वो कोई भी फील्ड हो. Everywhere we are losing our access of balance and harmony. Why? Because we have to prepare ourselves accordingly, and this is the day, Science Day, to remind all of us that ultimately, जैसा वो विप्लव जी ने कहा था शुरू में, कि अगर वो ये गौर गरीबों के घरों में वो इलेक्ट्रिसिटी नहीं होती है, when he was talking about this aspect, so वो पहुंचाने की बात है, उनको ये सुविधा देने की बात है, मानवता के लिए कुछ कर गुजरने की बात है. जितना भी काम हमारे यहाँ भारत, हम बाहर की टेक्नोलॉजी को बहुत महत्व देते हैं, लेकिन आज मैं ये आपसे कहूँगा, अनुरोध करूँगा, क्योंकि मैं उस फील्ड से बिलोंग करता हूँ. आई एम नॉट ए साइंटिस्ट, बट आई कैन कोरिलेट that if our Sankhyan philosophy, if I talk a few words, what is this mother nature we are talking about? Our scientist Kapil, who is said to be Rishi, and who is the Rishi? Those who have seen something with not with these eyes, with the different eyes. And he has established that this Prakriti is nothing, but it is a combination of three things. What is that? In our traditional language, it is said, it is Sattva, Rajas and Tamas. If I translate it in scientific language, I would say this Sattva stands for the protonic energy, this Rajas stands for the electronic energy, and the Tamas stands for the mass, the inertia. So scientists are also trying to understand the hidden aspect of this Mother Nature, and our spiritual scientists, they have tried and they have reached to that state. They have also tried similarly. Only thing is, if I want to talk with my students, those who have come from the different institutions, अगर मैं उनके साथ ये बात करूंगा तो मैं यही कहूंगा कि सबसे पहले, ये सब जाने से पहले आपको अपने आप के ऊपर कॉन्फिडेंस लाना है. You have to develop that confidence within you. Yesterday I was talking about कोई program day before yesterday. I took the name of Albert Bandura, who is a psychologist. उसने एक concept दिया है. आप Google करोगे, ये जो कुछ भी आपने सुना पढ़ा, अगर सर कहेंगे तो सब आपको Google में मिल जाएगा कि क्या क्या हुआ, क्या क्या हो रहा है, सब मिल जाएगा. और ये भी मिल जाएगा, वो सेल्फ एफिकेसी का कंसेप्ट दिया. अल्बर्ट बंडूरा ने सेल्फ एफिकेसी का कंसेप्ट क्या है? यस, ऐसा सोचना है. यस, आई कैन डू इट, लेट मी ट्राई, आई कैन डू इट. दैट काइंड ऑफ कॉन्फिडेंस यू हैव टू डेवलप. इस कॉन्फिडेंस के साथ साथ आपको एक और बात ध्यान रखनी है, क्योंकि अभी आप 8वीं में, 9वीं में, 10वीं में पढ़ रहे हैं, और जो गलतियां हमने 8वीं, 9वीं, 10वीं में की थी, हम चाहते हैं कि आप वो गलतियां ना करें, क्योंकि हमने कुछ गलतियां की थी, हम चाहते हैं कि आप ना करें. तो आज से आपने अपना टाइम मैनेजमेंट आज से शुरू करना है. योर टाइम मैनेजमेंट इज योर रिस्पॉन्सिबिलिटी. नो वन एल्स कैन टेक दिस रिस्पॉन्सिबिलिटी. आपने टाइम मैनेजमेंट आपका खुद ने करना है. आपका बिहेवियर आपकी रिस्पॉन्सिबिलिटी है, दूसरा किसी की जिम्मेदारी नहीं. अभी आप थोड़े स्कूल से, मैंने वो किंडरगार्टन से, केजी से, अपर केजी से, यहाँ से होते हुए अब 8वीं 7वीं तक आ गए, 9वीं तक आ गए. तो ये आपकी अभी जिम्मेदारी है. रिमेंबर, योर वर्क विल बी योर सिग्नेचर. आज हम कितने साइंटिस्ट का नाम लिए, आज हम चंद्रशेखर वेंकट रमन जी का नाम ले रहे हैं, और कब 1930 में उनको नोबेल प्राइज मिला था. 1930 में. आप ये जान सकते हैं, ये कंसेप्ट जो उन्होंने, सर रमन, और उनका जो क्या बोलते हैं, वो जो इन्वेंशन था उनका, रमन फैक्ट. यस, सिंपल बात है. वो सर ने अच्छी तरह से आपको बताया था कि कैसे वो, अगर वो ट्रांसपेरेंट मटेरियल से लाइट जब गुजरती है, पास करती है, तो उसमें क्या होता है, तो उसमें कुछ वेवलेंथ चेंज होती हैं. वही इफेक्ट है शायद वो, जिसको मैं हिंदी में ट्रांसलेट करने की कोशिश किया. मुझे क्या लगता है कि ये दो बातें, और दूसरा आज ही इसके साथ साथ में, पहला क्या कहा, ये कॉन्फिडेंस की बात है, दूसरा बहुत सारी टाइम मैनेजमेंट है, बिहेवियर मैनेजमेंट है, आपका वर्क विल बी योर ओन सिग्नेचर टुमारो, और उसके साथ साथ में सेल्फ डायरेक्शन होना बहुत आवश्यक है. ये भी बात आपने ध्यान में रखना. यदि आपको कहाँ जाना है, वेयर यू वांट टू गो, वेयर यू स्टैंड टुडे, यू हैव टू थिंक टुडे वेयर यू स्टैंड, एंड यू हैव टू थिंक वेयर यू वांट टू गो. और उसके लिए क्या क्या रास्ते अपनाने पड़ेंगे आपको. इसके लिए अगर आपने आज ही डिसाइड कर लिया कि मुझे यहाँ जाना है, तो निश्चित रूप से अकॉर्डिंगली योर एनर्जी विल बी चैनलाइज्ड. एंड वंस दिस एनर्जी इज चैनल, होता क्या है फिर, ये जो साइंटिस्ट लोग हैं कैसे इतना सब करते रहते हैं, ये भी ऋषि हैं. आई यूज्ड टू कॉल देम ऋषि, बिकॉज फोकस कितना है उनका,
ये फोकस के कारण ही सब उतना जा सकते हैं, उस लेवल में जाते हैं वो लोग। उनके थॉट में, उनके थिंकिंग में ऑर्डरलीनेस होता है। हम लोग कभी एक बात सोचते हैं, कभी दूसरी, कभी तीसरी, और जंप करते रहते हैं मंकी की तरह एक शाखा से दूसरी शाखा पे। परंतु ये साइंटिस्ट लोग जो हैं, ये कंटिन्यूसली फ्लो ऑफ देयर थॉट कंटिन्यूसली, इट इज मेंटेन्ड फॉर ए लॉन्ग पीरियड ऑफ टाइम, एंड देयरफॉर दे कैन डाइव डीप इनटू, जहां कहीं भी जाते हैं ये इस प्रकार से जाते हैं। तो ये बहुत आवश्यक है आपको। इसके लिए हमारे सुंदर बात कही एक योग विशिष्ट में कि मन ही मनुष्य का बंधन का कारण है, और मन ही उसके बाकी सब रास्ते खोलने का भी वही कारण है। तो इस मन को, इस माइंड को आपने अगर अच्छी तरह से ट्रेंड किया, उसको ट्रेनिंग के लिए ये जो मैं बात कह रहा हूँ, यदि डिसिप्लिन किया अगर आपने, तो मुझे लगता है कि आने वाले समय में छोटी छोटी बातें हैं जो विकसित भारत के लिए आज हमारे नौजवान जिस तरह से आगे आ रहे हैं, उस तरह से मुझे लगता है कि निश्चित रूप से हम जो चाह रहे हैं, ये भारत विकसित होगा और निश्चित रूप से विश्व गुरु भी बनेगा। ये भी मैं रखता हूं इसमें। जिस प्रकार से वो एक ही शर्त है कि मेरे लिए क्या उचित है और क्या अनुचित है। वॉट एवर द एक्शन यू आर गोइंग टू परफॉर्म, बिफोर परफॉर्मिंग दैट एक्शन यू हैव टू थिंक ओवर द कंसिक्वेंसेस ऑफ दैट एक्शन, कि व्हाट विल हैपन देयर आफ्टर। मैं अगर ऐसा करने जा रहा हूं, करने जा रही हूं, व्हाट मेरे पेरेंट्स क्या सोचेंगे इसके बारे में, मेरे अदर गुरु क्या सोचेंगे, टीचर क्या सोचेंगे, ये मुझे नहीं करना चाहिए। मुझे ये करना जरूरी है जिससे मेरे टीचर का भी सिर ऊंचा होगा और जिससे मेरे माता पिता का भी सिर ऊंचा होगा। वो मुझे काम करना है और वो डिसाइड करना होगा आज ही। और तीसरी बात जो लास्ट में मैं बताना चाहता हूं, जो कि आपके लिए, always I used to talk about the 3H. What is this 3H? It is your head, heart and hands. हमारा जो प्रीवियस एजुकेशन सिस्टम था, ये न्यू एजुकेशन पॉलिसी आने के पहले और अब तक भी वो थोड़ा थोड़ा चल रहा है, उसने सिर्फ हमारे हेड को डेवलप किया, लेकिन दैट एजुकेशन फेल्ड टू प्यूरिफाई आवर हार्ट, एंड देयरफॉर हिरोशिमा नागासाकी में जो हुआ वो इसी कारण से हुआ था और कोई रीजन नहीं। देयरफॉर देयर इज ए नीड, आज आपको ये सोचना होगा कि हमको ये इंटीग्रेशन करना है इन तीनों में। जो कुछ भी आप सोचें, अगर वही आप बोलना शुरू कर दें और जो बोलें उसको आप करें, तो मुझे लगता है कि यही एक तरीका है, यही डिसिप्लिन बना देगा और आप अपने माइंड को ठीक ढंग से ट्रेन कर पाएंगे और वट एवर यू वांट टू अचीव, यू विल बी एबल टू अचीव। आज का ये जो जिन वक्ताओं ने मेरे से पहले आपको इस दिन का महत्व भी बता दिया, हिस्ट्री बता दिया, आज दिन तक क्या हो रहा है, कहाँ दुनिया जा रही है, किस लेवल पे जा रही है। आप इससे प्रेरणा तो आपको मिली होगी, लेकिन उसके साथ साथ में, उस प्रेरणा के साथ साथ में ये भी ध्यान में रखना है कि आप यू विल बी और यू आर एंड यू विल बी द बेस्ट मास्टर ऑफ योर this body as well as of your mind. So you have to develop that coordination between this both and you will be able to do. So 3H, head, heart and hands, ये इनका बहुत, अगर if I talk in terms of volume, because in education landscape this Bloom taxonomy is more prevalent now. तो ध्यान रखना आपका cognitive aspect of your behavior, psychomotor aspect of your behavior and affective aspect of your behavior. These three, if you are failed to integrate, nothing can be achieved. If you are able to integrate, anything can be achieved. Therefore, इस head, heart, hand को इसको बराबर से इंटीग्रेट करना वही है। तो पर्सनैलिटी तभी बनेगी आपकी जब ये इंटीग्रेशन, जैसे जितना जितना इंटीग्रेशन होता जाएगा उतना उतना पर्सनैलिटी भी निकलती चली जाएगी। कीपिंग दिस इन माइंड, आई थिंक वंस अगेन आई कंग्रेचुलेट डॉक्टर मिश्रा जी एंड हिज कलीग्स and the whole entire organizing team for organizing this program and giving this chance to the students from the different colleges. बाहर के भी बच्चे हमारे यहाँ आए और उन्होंने श्री श्री यूनिवर्सिटी में, कैसा लगा आपको श्री श्री यूनिवर्सिटी में आकर के कैंपस में? कैसा लगा? अच्छा लगा? उड़िया बुझबे नहीं, हाँ, और बोलने में भी आ नहीं सकता है, तो इसलिए तो कभी भी आप आ सकते हैं, इसको अपना घर समझ करके जब भी आपके मन में आए तो आप कभी भी विजिट कर सकते हैं। हमारे साइंस डिपार्टमेंट के टीचर्स हैं, एनवायरनमेंट के प्रोफेसर्स हैं, फिजिक्स के प्रोफेसर हैं, मैथमेटिक्स के प्रोफेसर हैं हमारे पास, तो ये सब आपको कुछ जो भी आप मदद चाहें उनसे तो वो भी ले सकते हैं आप। और कहीं भी हेजिटेट नहीं होना, कहीं कुछ अपने आप को आगे बढ़ाने के लिए जिस किसी से भी मदद की ज़रूरत पड़ती है तो हेजिटेट नहीं करना, इमीडिएटली बोलना हाँ हमको चाहिए, हाँ। और सबसे ज़्यादा निश्चित रूप से रेडियो में इसमें उसमें सर पानीग्राही सर जो हैं वो अवेलेबल हैं सब जगह, तो पानीग्राही सर को भी पकड़ के रखिए, हाँ, निश्चित रूप से सफलता मिलेगी। इन्हीं शब्दों के साथ आप दोनों का बहुत बहुत धन्यवाद, क्योंकि आपने मैं तो स्पिरिचुअल साइंटिस्ट हूँ, मुझे तो पता नहीं है बाहर की साइंस का, लेकिन मुझे बहुत अच्छा लगा क्योंकि आपने मेरे लेवल पर आकर के मुझको समझाया। थैंक यू वेरी मच।
I will hold you for a minute and I will request our Dean Sir, Amarendra Narayan Mishra Sir, for the felicitation ceremony. I will request our faculty members, Gyan Sir, Rajiv Sir, Vikas Sir, Suhasri Ma'am. I will request our VC Sir to felicitate Dr. Joy Krishna Panigrahi Sir. I will request our Dean Sir to felicitate Dr. Biplav Kumar Patra Sir. And I will request our faculty members, our Gyan Sir, Satyajit Sir, Vikas Sir, Rajiv Sir, Suhasri Ma'am, Snigdha Ma'am for a group photo. Thank you, sir.